Hey guys, oops, sorry. All right, we are recording, so let's get started. A few things on the agenda today. Um, One of the things is we're going to do a new example. So you built the PyTorch model, right? So you know how to do that with a multi-layer perceptron and deep learning. You built your first one for Iris. Iris is pretty easy and straightforward. Usually when I do this, I do two. I do Iris, which is super easy, and then I do something called the wine quality data. And those are kind of like the intro of PyTorch and deep learning, and then we're going to start drilling down into like the sequence from linear regression all the way to deep learning, and we're going to go over sort of the important concepts that are going on there, including the loss functions and things like that. So today we'll do the wine quality example. The first thing I want to do is, as you know, we need to use GPUs on in some of these assignments and in deep learning in general. So there are essentially two approaches to this, unless you have your own GPU at home. One is to use Scholar. We've been having issues with that. So today I'm going to show you the alternative to Scholar, which is something called Colab. Colab is by Google. So the only issue with that is you have to have a Google account, right? So if you've never created a Gmail account, you're going to have to, and you have to be logged in. So log in if you want to follow along, which I recommend. Just log into your Google on your computer, and then after that, we're going to try to reach Colab. It runs kind of like the Jupyter notebooks, but as Google being Google, everything is different with them. So it's going to be some slight difference. So I'll point out what it is. The advantage should be that you should be able to get a GPU real quick. The downside of this is that Scholar is a little bit more unlimited. Google might be well, I would assume if you're training a lot, right, at some point they may want to take your money. So be careful with that, right? But otherwise, that's the thing. It's definitely powerful. Colab is definitely something you should know, and it can definitely help you sometimes. It's just those two things. Google, obviously, you have to be logged in, and you have to at some point, it's free initially, but at some point it may not be free forever. Okay, so let's get started. So I've already logged in to my Gmail here. And so I'm gonna just open a browser essentially, and I'm gonna show you the basic functionality of Colab. All right, so I just type Colab here. Colab is if you guys ever do job interviews and things like that for data science, they'll probably expect you to use Colab. They're not going to say, oh, yeah, log into the Purdue Scholar. You know what I mean? So it's a very, very well known. So I've always been a little bit resistant to Google, but you have to get with the program eventually, right? So yeah, so essentially I open it here. I'm going to click on New Notebook, right? So you can see that there. There we are. It's a little bit, I would say it's almost like Jupyter Notebooks. It has even the same extension, but their interface is very busy versus the interface that we're used to. But I'll show you, I like to start with a fresh copy. Okay. You can add cells, you can add like code and text cells and so on. So I'll just essentially go over these. So this is a cell, okay? One of these rectangles here is a cell. Instead of having a button up here where you run, the run button is this little black circle with a triangle. So that's your run button. Okay, if you want to add more cells, you just do code, code like this, and it adds a few more cells. To it, obviously, as you can see, they're very big on helping you the code. So they provide generate with AI. This is probably using Gemini, and I'm sure is pretty good. All right, so something that you can play with. But you can also write your own code, right? So you can write your own code here. So that's kind of what I'm going to do in this example. So now the key thing is, it creates like almost like an anaconda environment, right? So once you start doing something, you can't really like modify. Okay. And so I would recommend, I have had this problem before where I write a whole bunch of code and I'm done with it. And then I forget that it was CPU or GPU, and I had started with CPU. And then when I made that one change, lots of things were going to work. So go ahead and click on runtime here. And when you scroll, this is pretty important. When you go to change runtime type, you'll see that it gives you options to use various processors. If you use CPU here to do something really big, like training the ResNet at the end of the semester with Sci-Far 10, that it'll take a very long time, right? So you're using the CPU. So you want to select T4 GPU, okay? That would be a GPU. I have tested this several times and it works really well. These A100, A100 GPUs, if you notice, are not available, but they kind of like show them to you, right? I'm pretty sure it's a paid option. But it's nice though. If you're ever doing something pretty big or something like that, it might be worth just paying and getting that job done in a second. Right. Also notice that it provides Google's TPU. So this is like a GPU, but it's Google's own uh, in-house developed chip, and it's called a TPU, which stands for a tensor processing unit. Only Google has these. They don't sell them as far as I know. But yeah. Okay. So that's essentially all you have to do, right? So you select T4 GPU, click on save. So now essentially in your environment, you should be running GPUs. Got it? All right. Now, one thing, I have a few commands here. Where do I have them? All right. So this is Brightspace. So I always keep like my own commands. So I'll be using that just kind of for the lecture today, or for this demo, sorry, for just this Colab demo. Here. Right? And I'm going to call it. The commands are pretty consistent with the Jupyter Notebook, so it's not like they're going to be different. One thing I always check, of course, is the Python version. I'm sure there are ways to change the Python version. I leave that to you to figure out. My suggestion, go play with Colab, right? Get a feel for it, read everything that you can about it. But this should allow you to see the version of Python that we have installed. See, I hit run there. It does this little message thing that is showing to you, and then it says that I'm using Python 3.11, right? So that's a fairly advanced version of Python. Okay. All right, then I'm gonna do another cell here, and I'm just gonna import Torch. Hit the little button there, and you can see it provides this little check, these little checks, which tells you that everything worked out. If there had been a problem, it would have given you an error, essentially. Got it? That's it. I mean, as you can see, it's pretty consistent. But as I said, you have a GPU underlying now. It's just I don't know for how long, right? So, hopefully for the whole semester, but you guys will tell me. All right, this is an alternative to Scholar. So, very soon I will be assigning homework, the next homework with PyTorch, and it'll most likely use a data set. Yeah.
So you don't have a dedicated GPU.
If you have your own GPU at home and it supports CUDA libraries and you've installed the drivers and everything, I encourage you to use your GPU.
Okay.
Yeah, definitely. It's the experience you want to get. Yes, sir. Of course. Yeah, if you have Windows Server, I assume, a Windows. Yeah, it would be how you installed Anaconda. Yep, exactly. The software Torch one of the things it tries to do is it tries to find if you have a GPU. So it looks for it, and if it finds it, it's gonna want to use it for sure. All right, great. All right, so yeah, so I'm giving you this other option. You should know it for sure. Colab is everyone will talk about it. As I said, you just have to have your Google account. I'm already logged in. They are tracking, so they're gonna ask you for money at some point if you want a better GPU or if you're training for a very long time and all that. And I'm sure they have several pro or medium or student, so you have to look into all that. All right. And we're still working on Scholar to see if that we can get that for you also. All right, so I'm just going to do a few examples of this really quickly so that you guys get the picture of it. And then, as I said, you have something. So for instance, I'm going to do, just I have Torch here. All right. If you want to install a library, it's exactly how you would before. Pip install scikit learn or something like that. See, the requirement is already satisfied. Obviously, Colab is like, the focus is AI, right? It's got AI generated code, and, everything is going to be there. So it's kind of nice, but, and I've resisted a little bit Colab because they just provide way too much, like a little bit too much to the point that you don't really know, you're missing out on some of the knowledge. But it's a great op. Now that you guys, though, I will say, now that you guys have had 8 weeks or so of the semester, you've mastered all the other techniques. So Colab is, perfectly fine. Let's say I want to install another library. I'm going to do pip install transformers. And it's installing the library, as you can see, and it finished, and it's available. And yeah, that's essentially everything. Got it? Yeah. All right. So I've given you this tool. Remember, the key thing is this part here of changing the runtime, and so change runtime type, and selecting the processor that you need, the GPU, etc. All right, great. So we've covered this topic now. We're finished with the homework assignments. As I said, next week I'll probably assign the third homework assignment, and I just haven't decided, if it's going to be two or just one, but I'll let you know. I'm thinking about it. All right. So today on the agenda, the plan is to go over another example called another PyTorch example using the database called wine quality. So let's go to Brightspace here. And I will remind you, we are in this module here, the classic Iris torch to motivate and ends. I have provided this link topic notes, right? And it's essentially the next few weeks of class, right? It's everything. So please make sure, if you haven't done so already, that you're reading through this material. Everything should be explained in there that we're going to be covering, and we're going to start getting into some of the details, right, of how things work. So today I still want to do wine. I want to do wine quality, which is going to be, so this, whoops, which is going to be problem down here. And then we'll cover, yeah, so it's going to be wine quality data set, right? And we're going to be covering that. So EC, I believe EC deep learning was the Iris example that I covered. And now I'm going to cover more challenging deep learning with the wine quality data set. Okay. But, as I said, maybe when we first looked at the perceptron, it seemed overwhelming and so strange and alien. But the great thing about everything now going forward is how consistent it is, right? It's almost like the same thing, almost repetitive as we go forward. One key thing that we're going to see about Iris is that the data is no longer balanced, right? And this is one of the challenges of the problem that I want you guys to see. And you'll see my performance is not going to be the best, but you'll see me talk about the things that I think we should do to get better results. Okay, so everything is here. All the results and everything are provided in the description. And today I'm just going to go over this. Okay, so let's go ahead and Okay, so go back to Brightspace. I'll close this window. I remind you to please read it. If you haven't done so already, I'll close this one. So I'm going to go here. All right, so just like the notes are provided in that link, then of course there's the repo, and you can click on that, and the code should be there. So it's here. Remember also, I'll remind you, so if we go to the Machine Learning Foundations repo, that I created a folder called 2025, where every script that we do in class gets loaded here. So all the 2025, so this is 2025. So if I remember correctly, so we've done KNN, we did perceptron, we've done hot field networks, and we've done the in-class torch hierarchies, right? So these are the ones that I'm doing in class. Today we're doing in-class torch line. All right, we'll go over that one, and if this is where I'll load it here. Okay. All right. Well, that's good. But this will be my in-class. So this is where I have the link from the repo. So you can see we need the data. So there it is, wine quality .csv. And we're going to be doing this one. So classification DL IPython. So all the code that I'll be doing today in class, you can just get from there and read at your own pace. Okay, any questions? All right, so let's go ahead and get started. So I'm going to create a Jupyter notebook here. Oops. Hit all. Anaconda prompt. All right, so it's loading the terminal there. dir cd desktop dir cd. It should be 365 2025 spring. Okay. Then in here, oops. Then in here we have my PyTorch. So that's where I'm gonna do this. Okay. We go there, dir in-class torch iris. So I'm just going to create a new one. Obviously, I need to download the data set, and I'm going to add it in here. Okay, so that's what I'm going to do next. So it'll be this one quality CSV. So I'm going to click on that. Right, and I'm going to download it. Right, should be on the downloads program. Downloads. And I'm going to close this again. Let's try this again. I don't know why it doesn't want to open this. Oh, there we go. All right, so should be in here. There it is, wine quality, control copy, go to the desktop. I'm going to move this to 65. Right, PyTorch. There we are. All right, so I have the data sets, and I'm using a CSV file. Yeah. So now that we have the file available, we can probably see it from here. It's right there. Now I'm going to select an environment, so Conda environment list. Yes. All right, and I'm going to do Conda activate, and it's going to be so Conda activate Pi 37 2025 underscore ITS 365. All right, so we are in the environment now. So let's do Jupyter Notebook. Jupyter Notebook, start it up, and we're going to start creating our script. It's a different data set, but the idea is so hopefully with these two examples, I think you guys have a good understanding of PyTorch and neural networks. And then we just start drilling down from linear regression, which you should have covered in one of your SAP courses, logistic regression, multi-layer perceptron, deep learning. And there you go. And then after that, we are at the third of the semester where we're covering advanced topics like CNNs and ResNets, which is kind of to round out the topics. So let's go ahead and start Jupyter Notebook here. So I'm going to do Python 3. Whenever I connect, slows down. It's always updating. Oh, all right, so let's create a few cells, right? And we're going to start processing this. Okay, so I'm using, let's change the name since I'm going to add this to that folder. So I'm going to rename it as in class. And this is going to be Torch. And then this is going to be the wine quality data. Wine quality is actually a regression data set in a sense, but you'll see how I'm going to just convert it into classification. I'm playing around with this idea, and really it should help you to understand the very simple difference between the two. Okay, so regression classification is kind of like the two sides of the same coin, if you want, as far as the inference function is concerned. So in class toward wine, here we are. All right, so now we go to our chapter section here, and I'm going to be using this one. So let's take a look at it. All right. So the libraries, this environment probably has all these libraries already, but we'll install as needed. So you can see, same as before. So libraries are, NumPy, Torch, Pandas, sklearn, and then from Torch, Torch.nn, which allows me to define the architectures of a neural network, Torch, and then functional, which allows me to bring in loss functions, which are the thing that compares the error, if you remember, and then Torch top, and just here we are. Okay. All right, so we're back. Okay, so yeah, so as I was saying, this torch NN is whenever we're defining an architecture like a multi-layer perceptron, etc. So let's go ahead and run this one. I'm going to hit run. There we are. Okay, then I'm going to add, some more libraries here that are familiar to us now. So matplotlib, this one for plotting the heat map from MLX10, sklearn, of course, and the data loaders that we learned about on Monday. So I'm loading my libraries, no issues here. Everything's good. Then we are going to need these metrics, which is what I'm using for the performance, measure performance, just that function that we've been using, I think, ever since KNN. Okay, so that's done. And as you can see, XGBoost, this is one of the things that I want to cover at the end, at least. This is a good library, actually, you should know about for tabular data, but we're not going to use it today. This is Onyx, so Onyx runtime. So this is one of the mechanisms that we can use for deploying PyTorch models to the web, similar to how we did PyScript. Just it would be a more powerful Torch model, but I'm not going to do that today. All right, so let's just focus then on building a neural network for the wine quality data, right? So for we have to first try to understand how wine quality works. We're going to look at the data, get a feel for it. But as you remember, we defined something called the batch size, which essentially means that we show the neural network 32 samples at a time. We show it 32 samples, then we show it another 32 samples, and so on. So that's what batch size means. Learning rate is the value that when we're updating the parameters, such as the weights and biases, right, we add or subtract this value, right, from the parameters. And then nepics is just, again, repeating the data, how many times we show all the data to the model. So we've discussed all of this. Epsilon is so that whenever we're dividing by zero, we don't have a divide by zero error, so we add a little epsilon in there just in case. So I'm going to hit run here. I'm going to add a few more cells. Okay. So here we are. Now I'm going to read in the data. I have my data available, and then we're going to visualize it. So the very first thing I'm going to do is just get that data and take a peek at it. All right, so the path is the wine quality white CSV. That's our data set that you saw me download from the repo. I'm going to use pandas to read in the data. That's usually what I like to do. I like to process the data and do all of it in pandas, as pandas is really powerful for that. The limiter is semicolon, which is probably correct. They can have different, actually, yeah, makes sense to look at it. So as you can see, the delimiter is not a comma, but instead it's a semicolon. So that's why I'm changing it. Let's go back. All right. So run it. Here we are. Now we've loaded the data into a pandas data frame. And so now we want to proceed to look at the pandas data frame. So I'm going to hit run again. Okay, and here we are. This is where you first start to do machine learning, right? Shapes. If you remember at the very beginning of the semester, I said, what is X? What is Y? What is the shape of X? What is the shape of Y, right? So your whole mind should start working that way. So here we are. What do we know? We have 4,898 rows. Okay, that's the sample. So this is a slightly larger model, right? 4,898. Keep in mind, MNIST is going to have 60,000, and so things get large. And that's by no means big data. Those are tiny data sets today. ChatGPT was trained on all of the internet, right? So think about that. All right. So the other thing is the feature. So you have 12 columns. So we want to understand about the features. So quality, the last column is going to be what I'm going to use either for regression or for classification. Why am I doing this? I just chose, I wanted a data set that I could use for both things. And I can, if I can make it a regression if it goes from 1 to 10, right? So it's a regression. The only thing is sometimes it'll predict 3.7. Sometimes it could predict 7.6. So I could build a neural network that does that. Or I could build a neural network that predicts 1 of 10 classes because it's a rating, right? So it could predict 3 or it could predict 7 or it could predict 8 and so on. Get it? A rating system can work both discretely and it can work as a regression value, given that the rating 7 is greater than 3, right? It has a higher rating, but it can also be a label. Got it? So that's why I kind of chose this data set. What it means is they're rating, I believe, white wine. And so the quality is, what this wine is a 1 versus this wine is a 9, right? And so, there's universities in California, I'm pretty sure in UC Davis, for instance, they have a wine department and things like that. And what they do is they're just looking at what are the factors, right, that we have to focus on to improve this wine. So this is what this model is doing. So for instance, they measure, I'm sure with chemicals and things like that, they measure fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, the density, the pH balance, sulfates, and I guess the level of alcohol in the bottle. And all of those factors are used to give it to a model, and the model is going to say, oh, based on this, I say the rating is a 7 versus a 2. You guys get it? So that's the problem that we're dealing with. This data set, we can look at various things about it. So some values are seem to be around 6 or 7 here. So these are in a scale of 6 to 7. These are in a scale of 0.20 to 0.27. Look at how narrow that is. These are also in a narrow range. Residual sugar can go from 1 to 20. That's a very, big range for the change. Look at these are in the 0.0 something. These seem to be from 20 to 45. These over here are in the 100 range, right? So lots of ranges. So definitely for this data, we want to normalize, right? Remember that when you scale the data via standardization or normalization, what's going to happen is now we're going to get for all these columns the equivalent values in some range from -10 to +10 or -1 to +1 or 0 to 1. As long as they're all within the same range, they've been normalized and the neural network should behave better. Okay? So that's one of the things that I want to do today is get this going. I like to do the normalization in the neural network, so that way I can always use real data, but the neural network normalizes. All right, so we'll take a look at that. Anyway, so we've ran the data. This gives us a big picture of how everything works, and we know, okay, I know what my task is, so now I'm going to go ahead and build a neural network. You guys remember Weka? If you loaded something like this in Weka, or obviously bring in some feature ranking Python code in here, this would tell you which one of these variables is the most important to improve your wine quality. You see how valuable that starts to be, right? Because now you're like, okay, where should I start? Should I put more sugar in the thing? Do people think that makes it better? Or the opposite, right? Maybe they want less sugar. Maybe less sugar makes it drier or something, and that makes it more wine. So anyway, this is how you start to do this kind of work and to get some insights into how it works. But anyway, so we are trying to build a neural network here. So let's go ahead and continue. I've collected my data. I'll use the standard thing that I always do, the correlation coefficient matrix. Gives me some insights. I've got the columns, so I can plot them essentially. I want to create a correlation matrix. If you had a client, that maybe a farmer or something, that grows wine, and so you would show this data to them, and it might be very interesting. Okay, this is like data science, the data science part. All right, so I've done this part. I'm showing you here that you can also select some labels. It doesn't have to be all labels. You can tell it which labels you want it to look at. So here I'm creating headers list 1, and then I'm creating headers list 2, essentially. I'm going to hit run. So I'm going to hit save here. All right. So now let's do the data analysis. This is called a correlation matrix. And essentially, you think of it as comparing all the variables to themselves, right? So I'm going to do that here. And I usually do this, especially when I have a regression problem. I like to get a feel for things are behaving. Okay, there we go. It took a little bit, right? Because it's 4,000 samples of data now. But you can see it provides the information. Remember that the correlation on the diagonal is going to be 1 because the variable is comparing to itself. So it's going to match exactly. If we want to look at the quality, which is the variable that we have, we would look at these values. So negative or positive is, 1 is not better than the other. It just means that one is negatively correlated, the other one is positively correlated. So as one goes up, the other one goes up, or as one goes up, the other one goes down. Both are very important. All right. If there's a 0 correlation, then it means that that's not contributing much. So for instance, this metric, citric acid, does not seem to contribute a lot to the quality. Do you see that? So it's not something that you want to do anything with in your formula and in your recipe. I would say of all of these, 44, you see this one, alcohol, actually, seems to be the one that is most correlated to wine quality. Does that make sense? That's what it's saying. It's a strong correlation, I would say, there at a value of 0.44. The next one, minus 0.31, so the density, but it's in the negative. Yep, they are. Yeah, there you go. Doing some chemistry there. But yeah, exactly. So that's what this is telling you, right? So from the data that you collected, you can start to get lots of insights. Yes, sir.
Zero, that means there's absolutely no correlation.
No correlation. Not an important variable. So for instance, I look at citric acid or I look at this free sulfur dioxide and they don't seem to be important. But if it's negative or positive, yeah, it's important. Yeah, there is some, but I'm looking for what I need to pay attention to. You can think of it that way. So I look at these and I'm not going to pay attention to them first because I want to pay attention to this one and that one and start talking about it. So, okay. Make sense? Yeah, great. And then you have, this minus 17 and minus 19. So a lot of these seem to have a negative correlation, right? So there's that. And then alcohol seemed to be the only one that had a positive correlation. So lots of insights there and that you can start to get about your data. All right. Anyway, so I've done that. That can help whoever, like the chemist who's doing this, but also it helps you in machine learning to think, okay, what features might be important here? Now, this is not tied to the neural network at all. This is like another method, but it starts to give you some insight. Like if I need to drop a variable, the ones that I'm going to drop are citric acid and the other one. You see that? And this is something that we did in Weka also, if you remember, with Iris. I kept dropping variables until we arrived because not all of them were super important. Sometimes, remember, you drop variables and your performance might go down by a little bit, but it's something that you can live with. All right, so so we looked at the correlation. Now we're going to start the same thing we do always, process the data. We want to convert it from NumPy into PyTorch, okay? So I'm going to grab this one here. And I'm going to go back to my Jupyter notebook. All right, so convert the pandas data frame into a NumPy array, and we can visualize it if we want. But this is really large. So at some point, this starts to become meaningless. You see that? The view data that's so large that you're not really getting much from it. So that's why I've emphasized so much that the shape is sometimes a much better uh, view of your data. Right? We live by these shapes because they're essential to my neural network. Already I know some of the dimensions of my neural network just by looking at this. Okay. So I have my data as NumPy array. So now let's continue. So we printed the shapes. Now I'm going to go ahead and slice my X and Y. So if you remember, I taught you this approach that you wanted to start with a problem and end at X and Y. Because once we end at X and Y, then we can pick up from here, from that X and Y, to build our neural networks. So here I have my wine raw data, and you can see I want for X all the rows, but I'm going to slice all the columns except the last one. That's the quality. So that's the labels. You can see for the Y, I do the exact same thing. I grab all the rows, but I only grab the last column. This 11, 12, I just do it that way because I like the shape that I get from the tensor. I encourage you to try those. All right, so I run. So now I've sliced my data, my NumPy array into X and Y, which is similar to what we've done before. You can view Y here. And you can see that if they're not integers, they're decimal values. If we're going to do classification or something like that, you want to convert these into integers, which is what I'm going to do now. So I'm going to typecast this to integer. And this is similar to what we did before. Because as I said, some of this stuff starts to become repetitive. All right, so I just convert my y into an int. And now I can print out y. And there we go, integers. All right, let's keep going. So integers are converted. All right, so now I'm going to do the histogram. So you want to know when you're dealing with a machine learning problem, if this is balanced or imbalanced. That's really important. So I'm going to go ahead here, grab my set. All right. So I'm going to use from NumPy something called unique. I give it Y, and it's going to tell me which labels are in here and assign them to set. All right. So I run this, and I can see there's several issues. There's 3, 4, 3, 4, 5, 6, 7, 8, 9. Okay. So there were no ratings for 0, 1, and 2. So the wine was probably not like the worst wine in the world, right? So those labels were not there. However, the data loader does not like gaps in classes. So it's going to want to start at 0, 0, 1, 2, 3. So for the data loader to work fine, we're going to have to make a little change to this, but it's just a simple mapping. So I'm going to map 3 to 0, 4 to 1, and you can see where that's going. But that's it. There's no missing things. So it's 3, 4, 5, 6, 7, 8, 9. So that's fine. We don't want to have gaps. All right. So now that I have that, I can print out the length of it. So that's just so I know the exact number. There's 7 classes. Could have counted them, of course. And I like to view like a little histogram to get a sense of the data. Right. What do you think? So now I give you this chart on the exam and I say balance or imbalance. It's imbalanced. Yes. This is a problematic data set. This is why I've chosen it. So one class dominates, class 6, right? And then 5 and 7 really dominate the whole thing. 4 and 8 are very small, and you can barely see 3 and 9. But, well, so a couple of solutions. One is just drop 3 and 9. That's like you're the architect of this. You know, it's your choice. You can totally drop 3 and 9, right? And just leave it. You could even drop 4 and 8. There's an argument to be made. So you can do these choices, right? It just depends on the task and what you're trying to accomplish. But for me, for what I'm trying to show you, I'm going to leave them in there, right? To make the problem more challenging. Okay. But now you have it, you're encountering a data set that's more difficult. As I said, when we do the fraud, if we do the fraud quality or fraud detection one, that also has high imbalance. And those are challenging data sets. All right, so we plotted the histogram. Now we want to look at our X and our Y and get those shapes. So again, getting those shapes is so important. So we know we have 4,898 samples. The X data has 11 features, and then we have one column for the labels. All right. So I'm going to split the data now, as I usually do. I'm not going to use a constant, but instead, every time I run my Jupyter notebook, I'm going to create a seed value. That way it randomizes the data differently. If I run this Jupyter about 10 to 20 times, as I'm debugging it and everything, I'll start to get a feel for the tendency of the performance. All right, so I'm going to hit run here. All right. Now I'm going to grab the data and I'm going to split it into these 4. So train test split, that's from sklearn. I'm giving it X and Y. Test size, I want it to be 20%. The train set is 80%. And the random seed, as I said, is the value here. This will produce our familiar X train X test and our familiar Y train Y test. So that's what we use for training the model, and then we evaluate the model on the test sets. Go ahead and run that. There we are. All right, so I'm going to print the shapes. All right, so 3,918 samples to train. That's a good amount, I would say, of data for 11 features, and then 980 for testing. That's also a good amount of data. I like that. I look at that number, I'm like, okay, I can get some understanding of what's going on here. So, whoops. All right, so now that we've done this one, this thing with the sparsity, all right, that we had talked about. I don't know if it's my computer or the internet is coming up. Okay, so I think we're recording again. All right, so the next step, as I said, we look at the data type, float 64. This is actually a very important thing today, given that, if you guys are really trying to use AI models, etc., you really have to be able to play with the size of the variables. So I don't like to use float 64, and so I'm going to convert these to float 32. Right. The integer can stay at whatever that is, but I'm going to change the floats. All right, so X train and X test are going to be changed from float 64 to float 32. All right, and I'm going to leave the labels Y train and Y test as in 64. There's still numpys currently, but we're going to change these to torch. Be aware that there are equivalent functions in Torch. So I could be doing this directly in Torch. I'm honestly, NumPy is such a well-established library that I a lot of the time like to use NumPy, and I don't go into PyTorch. So it's absolutely necessary. So let's keep going. Um, Here we are. We've converted that to data type. The next step is to convert the data into torch tensor. So I'm going to take, I'm going to use torch dot from NumPy, and I'm going to convert xtrain, xtest, ytrain, and ytest into torch tensors. Okay, so that's done. Then I recommend that we normalize or standardize these values as we discussed before. So we're going to calculate the means and the standard deviations for this data. So remember, we did this on Monday, normalization and standardization. So I'm just going to calculate what they. All right, and as you can see, so this should be, we have 4,000 by 11. We average those out across the columns. So the mean vector should be 1 by 11, right? So I'm going to take this. You can see, we can print the shape probably. Right, and it is 1 by 11. We do the same for the deviations. All right, and we can save those, and we're going to use them later to normalize, to scale the data, basically. Yeah, go ahead, please.
How would you do it? I know there was a point in the last lab where I was having a really tough time trying to get the exact numerical.
Not the scientific notation, but you want the actual. Yeah, what are these, NumPy? Or they're torch tensors, right? So torch. So you can torch tensor show as not scientific. No. Right, I'm on my other computer. I'm just Googling it. So that's what I would do. Yeah, I get what you're. Give me a second. Probably with the means we want to do that. Is your internet very slow, guys? Okay, so we're all having problems, right? I'm not being like hacked or something. All right. Yeah, so it would be some command here. Okay, here we are. So disable scientific notation. So let's try it. It says torch dot set print options. And then you say scientific mode equal false. There we are. See that?
Like,
Yeah. Why? What do you mean?
should they be much bigger considering the output earlier had to do that thing or it does E plus and then the rest of the number. That's what I always interpreted that as.
Yeah, well, some are positive. So that means like 4.24, that this 0.01 here is positive. So that means it is like 42. I'm looking at deviations. Hold on. This.
Let's see.
And then, all right. So that one is in scientific notation. The other one isn't. So 6.85, where the x with this value is 0, 0, is just 6.8. When this is 0.02, so that becomes 138. You see, you have to look at the symbol, and there's like you move 2. Yeah. So yeah, so in 0, you don't, the dot does not move, but when it's positive and 2, it moves 2. So that 1.38 becomes 138. And the negative is in the other direction. Yeah. But yeah, if you want to see it in non-scientific notation, then yeah. All right. One important thing about these means also, if we look at them, they're, it would be recommended that they should be scaled because some are 138. This one is 0.27, right? So it's a big difference. So this 138 one, if you don't scale it, could dominate the whole model. All right. That feature could become almost more important than others because of that. And so you want to scale the data. All right. I'm going to do more cells and we're going to keep going. But we've calculated the x-means and the standard deviations. We printed them. Now comes the data loader. So again, it's very recommended that you always use data loaders. And you just have to know how to load your data on there. So we're going to print that we have 3,918 samples in our X data, right? Remember the label map. We're going to do that also because we don't want to have gaps in the data loader. So now effectively, we're going to do a label map and a reverse map, right? So it's almost like if we get this, it's, we convert it to this. And once we get that, we want to convert it back to the original. So this is it's just a way of doing things more quickly. So we convert 3 to 0, 4 to 1, 5 to 2, 6 to 3, 7 to 4, 8 to 5, and 9 to 6. So the labels are now going to be from 0 to 6. Make sense? But they're mapped to these original values. And we can reverse it with the reverse label map. All right, so we've established that. Okay, so now I'm going to create the lists. Remember, these lists go directly into the data loader, and it's exactly what I did with Iris. So remember, it's a list comprehension. So we say for I in range X shape, so that's 3,918 samples. We create a list of tuples. These are the tuples. The first part of the tuple is the X vector, and then the second part of the tuple is the label, essentially. So here, from X train TR, we grab the index. That gives us a vector, right, of size 11. And then we grab from Y train, by the index, we grab the number, and that number goes into the label map to convert it. So if we grab the 3, it'll become a 0. You guys get it? It's exactly what we did, and I would just recommend to be consistent in this approach. We do that also for the test. So we've created now our lists of tuples of torch tensors. All right, so hit run, finished. Okay. We want to take a look at one maybe. So that should be actually 3 elements